Section 2.2 continued. Defining slope-intercept form. The slope-intercept form of an equation of a line is y equals mx plus b, where m equals the slope, which we know from previous sections is rise over the run, but also can be defined in the formula by y2 minus y1 over x2 minus x1. Also, b is defined as the y-intercept. We know the y-intercept is where the line intersects the y-axis and must be written in the form of an ordered pair, and it is 0, b. Procedure to find the slope given an equation. 1. We want to copy the equation. 2. Solve for y. Eliminate fractions by multiplying by least common denominator on both sides. 3. That is your slope-intercept form. 4. Identify the slope and y-intercept. Let's look at an example. Here they want us to find the slope. Let's eliminate the fraction by multiplying both sides by the least common denominator. Here we have 3 and 3 and also 2, so our least common denominator is 6. 6 times 5 is 30, divided by 3 is 10x. 6 times a negative 2 is a negative 12, divided by 3 is a negative 4y. 6 times 1 is 6, divided by 2 is 3. Solving for y, let's subtract 10x. When I do that, I get a negative 4y equals a negative 10x plus 3. Dividing by a negative 4. And that 4 will have to go into each term, whether it goes in equally or not. That gives me a positive y equals a negative divided by a negative is 10 over 4. Dividing both by 2 gives me 5 over 2x. Positive divided by a negative is a negative 3/4. So our slope, using our slope-intercept form, is going to be 5/2. Rise over run. Our slope-intercept form also gives us our b, which is our y-intercept, which can be written in a form as an ordered pair, 0, negative 3/4. Our next example, we want to find the slope of this line. So let's solve for the variable. I know it's not y, but we need to solve for that variable. Subtract 4 on both sides. X equals 2. If I remember from previous slides, I know when I graph x equals 2, I can generate a table of x, y values. And here, since I know x is 2, no matter how many ordered pairs I write, x has to be 2. I can choose any value for my y, which would be 2, 0, 2, negative 1, and 2, 1. And I know that only this type of equation with just an x value generates a vertical line. And I know a vertical line has a slope that is undefined. So this is my slope-intercept form, but I also know that it's a vertical line which has an undefined slope. Let's take a look at another example to find the slope of this equation. I have a y value. I want to solve for y, so I'm going to add 9 to both sides. When I do that, I get a negative y. Here's my negative, equals 15. Divide both sides by a negative 1. And I get y equals a negative 15. This is my slope-intercept form. Here, if I graph this, y equals a negative 15, I can set a table up of x and y values. Y has to be a negative 15. and x can be any value, 0, 1, 2. I can count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I know that I have 0, 1, and 2. So I can have 0, negative 15, 1, negative 15, and 2, negative 15. That generates a horizontal line. But I knew that when I have an equation just solved for y, that it's a horizontal line with no x values. And I know that the slope must be 0. And on the previous slide, notice I don't have a y-intercept because my vertical line doesn't intersect my y-axis. But here, I do have a y-intercept. My y-intercept is at 0, negative 15. That's still our general form for a y-intercept. Let's look at one more example. Again, we want to find the slope, so we want to solve this equation for y. Let's subtract 2x on both sides. When I do that, I get a negative 3, y equals a negative 2x plus 5. Divide by a negative 3 gives me y equal to, negative 3 has to go into both, whether it goes in evenly or not. Negative divided by a negative is a positive 2/3 x. Positive divided by a negative is a negative 5/3. This is our slope-intercept form. And I can identify the slope and y-intercept. My slope is going to be m equal to 2 over 3, my rise over my run, and my y-intercept is 0, negative 5/3. The next slide has definitions for x-intercept and y-intercept. Here, the x-intercept is the point at which a line crosses the x-axis. And that is going to be defined as the x-intercept, which is x, 0. The y-intercept is the point at which a line crosses the y-axis, and we know that is already defined as 0, b, or I could put a y value here. Here's the procedure to find the x and y intercepts. X-intercept. In the equation, let y be 0, then solve for x. The solution is the form of an ordered pair. The solution for the x value, 0, which I already showed on the last slide. Y-intercept could be found two ways. Either solve the equation for y, which would be slope-intercept form, and the value would be b, or I could substitute into the equation 0 for x, and then solve for the y value, which again would be 0, and then the solution for the y value, which would be b. Let's look at an example here. They want us to find the x and y intercept of this equation. The x-intercept is found when I let y equal 0. So let's substitute 3x minus 2, and for y I'm going to put in 0, equals 4. And when I simplify, that's going to give me 3x equals 4. Divide by 3, and x is going to equal 4/3. And now that generates an ordered pair, 4/3, 0. Our y-intercept is found by either solving for y or substituting 0 in for x. So when I do that, I'm going to get 3 times, instead of x, I'm going to put a 0 minus 2y equals 4. That gives me a negative 2y equals 4. Divide by a negative 2. And y equals a negative 2. So my y-intercept is 0, negative 2. Again, they want us to find the x, y intercepts. I'm going to simplify by multiplying both sides by the least common denominator, which is going to be 3, 2, 1, 6. And that's going to give me 6 times 2 is 12, divided by 3 is 4x. 6 times a negative 1 is a negative 6 divided by 2 is a negative 3y. And 6 times 1 is 6. My x-intercept, found by letting y equal 0. So 4x minus 3 times, substituting for y, 0, is 6. And when I simplify, that's going to give me 4x equals 6. Dividing by 4, that gives me x equal to, divide both by 2, gives me 3 over 2. So my ordered pair is 3 over 2, 0. My y-intercept is found by letting x equal 0. So when I substitute, that's going to give me 4 times 0 minus 3y equals 6. That gives me a negative 3y equals 6. Or when I divide by a negative 3 on both sides, that's going to give me y equal to a negative 2. Therefore, my ordered pair is going to be 0, comma, negative 2. Again, finding my xy intercept. If I take a look at my equation, I know that x equals 4. I know that when I graph this, 1, 2, 3, 4, x is 4, and I have a vertical line. Therefore, I know that my x-intercept is going to be 4, 0. My y-intercept, I have none. On my next example, they want me to find the xy intercepts. Here I have y equals a negative 3. And I know if I graph this, this is going to give me a horizontal line. Therefore, I know my x-intercept is none. And my y-intercept is going to be the ordered pair, 0, comma, negative 3. Recall, here my slope is 0, and on the previous slide, it's a vertical line and my slope is undefined.